Following on from the previous video, we were trying to sketch this graph here. So we are increasing it from 0 to 4 pi. So here we've done up to 2 pi. We will need to go around again once more. So now it's 2 pi. So in order for us to sketch this, we will need to keep track of the radius. So we've drawn this in the previous video, and it gave us something like this. So what that means, what that means is when theta is 0. So when theta is 0, the radius will be 2. So the radius will be here. And then as we're increasing theta, by the time theta gets to pi over 2, so this is pi over 2, so pi over 2 will be here, pi over 2. The radius should be above 1.5, should be somewhere here. And then we're increasing theta. By the time theta gets to pi, by the time it gets to pi, the radius should be 1. It should be 1. So this is 1 here. So remember, the radius is 1, so it will be right here. And then we're increasing theta again. So by the time it gets to this point here, the radius should be below 0.5. So it should be somewhere around here. So we trace out. So from 0 to 2 pi. So from 0 to 2 pi, it will trace out this path here. It will trace out this path here. So we've done one. So we've done one circulation here. We've done one circulation. So by the time it gets to 2 pi, the radius should be 0. That's why it's right at the origin. By the time it gets to 2 pi. Now we need to go from 2 pi to 4 pi, meaning we will need to go around once more for the second time. So for the second time, by the time we get to here, so by the time we get to here, it should be the same as, well, it should be this. It should be right here. And then by the time we get to 3 pi, which will be here, along here. By the time we get to 3 pi to 3 pi, it should be back at 1. It should be the same as this one here. So these two are the same. It should be back at 1, which would be right here. So starting from 2 pi, will look something like this. It will look something like this. Badly drawn, but it will look something like this. So our graph will look something like this. It's just badly drawn. If you get a graph plot and plot it, it will give you this. It will give you this. It looks much nicer. But going back to here, it doesn't matter if you don't understand the following. But if you look at this, if I were to give you this, f of x equals x squared. This here is an even function, because if you apply the negative version, put it into here, it would be negative x squared, which would be the same as the original, meaning that if you, for our quadratic here, if you flip it, it will be its original. So this is very similar to that. As it turns out, this here is in a way an even. In a way, it is even. So whenever you have something that's even, when it comes to polar form, it will be a reflection along the polar axis, along here. So that's why our graph looks symmetrical along the polar axis. So that's why our graph looks symmetrical along here. That's why our graph looks symmetrical along here. Okay, so try and keep an eye out for something being even. So this in a way is being even here, because if you apply, so at the moment it's r theta equals blah blah. If you put the negative version in, meaning if you go the other way, in the other direction, it would be symmetric. It would be exactly the same thing. Don't worry if you don't understand this. I will give you more examples, and then hopefully you will get the grasp of it. Okay, so yeah, so overall your graph will look like this.